voltage, and what's my voltage difference between these two? Yeah, so it'll be, yeah, 1 volt is our difference between the two. We know that we're on our, so it's going to take our 1 volt, it's going to multiply it by the gain of either 100,000 to 200,000, that gives us 100,000. It's going to try getting it up to 100,000 volts. We know we can't do that because it's in saturation. It's going to go up to only 90% of our VCC. And since it's on the inverting pin, this one is going to swing down to, the op amp is just going to automatically go right down into saturation, and it's going to go to a negative 13.5 volts. Okay, so it's just taking the, taking the difference between these two signals, find out which one's more positive. If it's inverting, it goes negative. If it's non-inverting, then it goes positive. And it's just comparing our two signals. All right. All right, what's my, so which one's more positive, V1 or V2? V2. So we already know that my output's going to do what?
Go negative.
It's going to go negative. The difference between the two is going to be 3 volts. Taking 3 times 100,000 gives us 300,000 volts. We know we can't get that. We can only go up to 90% of our VCC, and it's going to go to a negative 13.5 volts.
So if we're in like the difference is like 100 volt, then we might be able to do something like 13.5 volts.
All right, so let's take a look at that. So what Tyler is saying is, what about if the differences of these two are so close? Well, that's one thing that we have to be, one thing we always have to be careful of is that ideally, and this is when you're doing your first lab, this is going to be one of the characteristics of this is going to be one of your characteristics that you're going to be looking at on your op amp. The first lab is just the characteristics of the op amp and looking at the data sheets and stuff like that. If I tie both of these down to ground and I get plus or minus 0 volts, ideally, what I would like to see would be to get plus or minus 0 volts out of my op amp. But when I'm dealing with such a large amount of gain, and because of the impurities of how this op amp is manufactured, that there's flaws inside this op amp. It's not going to be, these two input signals are not going to be balanced. They never are. You just can't, during the manufacturing processes, that these two inputs can never be balanced. But on the ideal op amp, if I put this one at 0 on an open loop comparator, if I put this one at 0 and this one at 0 volts, ideally I would like to get 0 volts on the output. But that's not going to happen. This op amp with this open loop comparator, what's going to happen is it's going to be unpredictable, but it's either going to go to our plus 13.5 volts or to our negative 13.5 volts. It's going to swing one way or another because of the large amounts of gain.
So
It's got to pick one, and it's going to pick one depending on how that op amp. So, Brad might grab his op amp, and he ties his to ground. His might go to positive 13.5 volts. You might grab yours, and yours might go to a negative 13.5 volts.
So ideally, this is always going to run at 13.5 volts.
Yep, one of those two voltages on an open loop comparator. Now, to make it predictable, so that we know what the output, what that output voltage is that what we need to do is have